derivatives. Andrew, what's my first derivative going to be for this guy?
So we got 2 and negative 1/3.
So 2x to the negative 1/3. Okay, good.
And then 2x.
Minus 2x. Okay, and if I wanted to, I could write that as 2 over x to the 1/3 minus 2x if I chose to. Okay, while you're at it, give me a second derivative.
Then you got, was that negative 4/3, or, oh God, you have to do some fraction math there.
Well, that's all right though. It's negative 1/3 times 2. What's that? That?
Oh yeah.
There we go. Okay, x to what power? There you go. X to what power?
And then negative 4/3.
There you go. Negative 4/3.
And then just 2.
Minus 2. Good. Okay. Okay, good. So we're just going to have to find critical numbers. So we're going to ask ourselves, first of all, what's the domain of this thing? We need to know the domain. Okay, we're going to go here. But the fact that that is an odd root, what's that telling us? Do we have problems with odd roots? Right? We can't take an even root of a negative number, right? But we can take an odd root of anything, right? The cube root of -8 is -2. So the fact that that's an odd root means that we don't have anything to worry about. The domain is all reals. We'll leave it there. What are we going to logically do to fill in our table here? Right? And this is a question of, are we going to use the first derivative test or the second derivative test to figure out what's going on at our critical numbers? We had two critical numbers, -1 and 1. What do you think? Should we use the first derivative test or the second derivative test? First derivative test, remember, I know it's been a week, right? First derivative test just means we're going to pick test points on either side of our critical number and see what the sign of the first derivative is. And that'll tell us if we've got a minimum or a maximum, right? We could do that, but we've already gone through the hassle of calculating the second derivative, right? So we might as well use the second derivative test. So at our first derivative critical number, we just need to determine what's the sign of the second derivative, because the second derivative is not 0 and it exists. Does that make sense? It would fail. If the second derivative were also equal to 0, then the second derivative test fails there. It doesn't have a sign, right? Or if the second derivative didn't exist at this critical number, then it would fail also. But we can evaluate the second derivative at 1. That's all we've got to do, is evaluate the sign of the second derivative at 1. So what do I get? If I plug 1 in for x, am I going to get a negative or a positive second derivative? I've got -2 times this factor here. What am I going to get? I got two factors. One of them is constant and negative. What's the sign of that factor going to be if I plug 1 in for x? Positive, right? Everybody agree? Positive. So I get negative times, they messed up my board over break. They did something to try to fix it and they thoroughly broke it. So negative times positive is negative, right? I get a negative second derivative. A 0 first derivative just means horizontal tangent, right? So negative second derivative then. Negative second derivative means concave down, right? So then we know it's a maximum, right? And we know negative second derivative. If the second derivative is negative, the function's sad, so it's frowning, and so it's a max. What about at -1? I could do the same thing. I know I've got a 0 first derivative, so I know this is a horizontal tangent line. I would just have to evaluate my second derivative at -1. And what am I going to get? Well, I get negative. If I plug -1 in for x here, what's going to happen to x to the 4/3 if I plug in -1? Keeping in mind that that's a 4. Think what that means. X to the 4/3 is the cube root of x to the 4th power, right? If I'm taking it to an even power, if the numerator of the fraction's even, what's the sign guaranteed to be? It's got to be positive, doesn't it? So I'm going to get negative times positive again. And so a negative second derivative is giving me my maximum again, okay? Okay, that's kind of nice. I almost know what's going on with the second derivative now too. Look, I know to the left of this 0 of the second derivative, I've got negative second derivative. To the right of this 0, I've got negative. What's the only thing I've got to do now to figure out if these are inflection points? What's the only thing I've got to do? Test a point in between. What point should I test? 0. Why not? 0 is the easiest point to test, right? So if we go up to our second derivative and we evaluate this thing, well, what's the problem there? Undefined, yeah. In fact, did we talk about this? Did we get a critical number for the first derivative there? We must have. Those are, okay, we found the zeros. I think that's where we left off. Y prime equals 0. when x equals plus or minus 1? Are there any places where our first derivative is undefined? Look at our first derivative function up here. So we're filling in our table. We've already filled in a lot, right? We filled in all this stuff, okay? Let's go back, though. Are there any places where our first derivative is undefined? Here's our first derivative written with positive powers of x. 2 divided by x to the 1/3 minus 2x. Any red flags go up there? Yeah, I'm dividing by x to the 1/3, right? So what value would have to be excluded? What value would make the first derivative undefined? 0, right? Because look, I've got an x on the bottom and I can't divide by 0. Okay, so we got another critical number then. Because of that, we know that y prime is undefined at x equals 0, right? Okay, so we can go back to our table and we can add the value at 0. The first derivative is undefined. Okay, well, so is the second derivative, right? So can I apply the second derivative test there? I can't apply it, can I? Okay. So what do I have to do then at that first, if the second derivative fails? Once again, they screwed up my board. Second derivative test fails, so what do I have to resort to then? First derivative, okay? Okay, so I need some test values, don't I? Okay. Well, I could use those values if I wanted to, right? I've already got them on my table. Those are kind of awkward ones to use, but that's all right. We could take our first derivative and we could evaluate the sign. Those are a little strange. Let's pick values a little bit easier. Let's pick something like, how about like negative 0.1 and positive 0.1? So if I evaluate my first derivative at positive 0.1, for example, what am I going to get? I'm going to get 2 divided by the cube root of 0.1 minus 2 times 0.1. We don't have to use a calculator on this. We could, right? We could evaluate this with a calculator. Do you see a way that we could maybe kind of reason through this? What's the cube root of 0.1 going to be? Is it going to be a fraction? Talk to me about that. Cube root of 0.1. I don't want an exact answer. It can be greater or less than 0.1. Yeah, okay, keep in mind that like 0.1 squared would be 0.01, right? Does that make sense? So a cube root is going to have to be a number that's greater than 0.1 because I'm going to take the number times itself and times itself again and get 0.1. So it's going to be a number bigger than 0.1. So 2 divided by a number bigger than 0.1, but still it's going to be less than 1, isn't it? Everybody agree? So that's going to give me something, this term is going to be bigger than 2, isn't it? Everybody agree? That makes sense? I'm going to have 2 divided by some decimal between 0.1 and 1. And maybe we can just think about it as some positive decimal that's less than 1 even. If I divide 2 by a decimal that's less than 1, I get a number bigger than 2. Minus 2 times 0.1, well, that's pretty small, right? Okay, dividing by a decimal is going to give me a bigger result than multiplying by a decimal less than 1, agreed? So what's the result going to be then? What's the sign going to be? It's going to be positive, isn't it? Okay. So we know that here we've got a positive Okay, what about at negative 0.1? What about at negative 0.1? What's that going to give us? So a cube root of a negative is going to be negative, isn't it? Right? So I'm going to get 2 divided by a negative decimal. That's going to give me a big negative number. Not big, but it's going to be bigger than 2, right? I'm going to get a negative number that's going to be less than negative 2. Negative 2 point something or negative 3 or something like that. Minus 2 times negative 0.1. So that's going to be adding 0.2. So I got a relatively big negative plus 0.2. What's the result going to be? Going to be negative. Okay, so then what's this telling me? What's going on at this critical number? What is the fact that the first derivative is undefined? What's that telling me about the shape of the extremum? If the derivative was 0, we had a horizontal tangent, right? Which led to a smooth feature, a smooth extremum. If the first derivative is undefined, what kind of shapes did we get for our extrema in that case? It's going to be a sharp corner, isn't it? Right? So we know it's a sharp corner going from a negative derivative to a positive derivative. So what's that going to look like then? What's that going to be? It's going to be a sharp valley, isn't it? Right? I'm going from decreasing to increasing. So it's got to be a sharp valley. Okay? Everybody agree? Okay. So then what about, we could start to connect some dots here, couldn't we? Okay, well, actually, we still need to know what's going on with this guy, don't we? Okay. We've got this 0 of the second derivative. Okay, it's undefined. The second derivative is undefined at 0, but we need to check some point to the right of this 0 to see what the second derivative is, to see if it changed. Okay. Well, we picked negative 0.1. That's a number between 0 and negative 0.439. So let's evaluate our second derivative at negative 0.1. Okay, so if we do that, here's our second derivative. This is factored. What's that going to give us? Negative times, that's always going to be positive, isn't it? Right? So I'm getting negative there. So that's not an inflection point, is it? Everybody agree? To be an inflection point, it would have to transition in sign, the second derivative would. It doesn't do that. I'm going to find the same thing at 0.1, aren't I? Right? I'm still going to get, that's always positive, that's negative. And so there is no inflection point there, right? And so I could graph this thing. What are we going to get? The shape of this thing. And I don't want to spend a lot of time on this, but we've got a sharp V, we've got a rounded peak and a rounded peak. So isn't it just doing something like this? Right? Something kind of like that. We agree? Okay. And we could plug in 0 and negative 1 and positive 1 and find the coordinates, right, of those points if we wanted to. Okay. All right.